This page we're looking at scatter plots and lines of best fit. So a scatter plot is these ideas here where there's a bunch of dots. This is actually pretty realistic because when you do a science experiment, you're not going to get exactly perfectly linear data. You're going to get kind of a scatter plot, and then you kind of generalize and say, well, my plot's kind of going up here. So it's going up to the right, and you can kind of generalize. So scatter plots are used to observe relationships between variables, right? You might be looking at the sunshine on the plant growth, a chemical versus that, the plant growth, how much rain, that sort of thing. Doesn't always have to be plant growth. But for example, height versus radius of a tree. Okay, and those two things are related to each other. So as a tree gets taller, it also gets wider. So you're looking at the relationship between the height and the width of the tree, the radius. The data does not fall in a perfect line like this, so it's dot, 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 so you get all this data, but we draw what we call a line of best fit. So we try to generalize and make a line that shows the characteristics, that the sloping up, this is sloping down, so you give it the characteristics of the points around it. The line of best fit, so this is a word that you need to know. It does come up where we say, but just draw the line of best fit. Just draw the line of best fit. So the line of best fit follows the pattern of the points. So basically, this is trying to show a pathway, and you're walking a line through the pathway. I wouldn't walk this way because you're not walking the pathway. You want to walk through the pathway. Right? So you're going to go, this pathway is heading up, so I'm going to walk this way, this pathway is heading up. You're not going to go horizontally through. So follow the pathway. What you're trying to do with your pathway, so when you walk your pathway, you might be like, so I can just walk anywhere, but you don't want to walk below it, and you don't want to walk above it. You want to walk right through the dots, as many as possible. So what they ask you to do is, there should be as many points above the line as there are below. So what they're asking you to do is walk through the middle. Don't walk below the line, the scatter plot. Don't walk above it. Walk through it. So you're trying to get as many above and below. Okay, so again, not below it, not above it, but through it. Okay, so if you look here, appropriate lines of best fit, these are trend lines. So I want you to analyze these and tell me if they're good or not good. Is this a good place to draw my line of best fit? Compare, look at these. Which one is good? Or which ones are good? This one is the only good one. Because look, it's walking through the dots, it's not tilted, it's not above it and not below, and it's following the pathway. So you're trying to walk this pathway. So this one is good. This one's good. It's going through all the points, not all the points, through the points, the group of points. The points, it's following the pattern, right? If I'm scattering these rocks here, that's the pathway, so walk through the pathway. These three, none of them are good. So this one's not good because it's too close to top. Too close to the top, right? So it's too high above. This one here, it's not good because it's not following the pattern. It says to walk up to the right, and you're kind of tilted too far. So you're not following the pattern. And this one here, sorry, also is not good. It's too close to the bottom of the points. Okay, does that make sense? Hopefully. All right. So then if we know that, then there must be a mathematical way to describe this. And what they do is on a computer, or you manually will add up the difference between each one of the points to the line. You're basically like measuring the distance. We're not going to learn how to do that this year, but eventually what they do is they look at how big of a distance there are between the points to the middle line, the line of best fit. So here, this looks really tight, right? Like that's a pretty good line. That is pretty tight with the points around it. This one is, it's okay. It's following the pattern, but look how scattered they are. So these two are much better. And these two are following the pattern, but not as good. So how do we say that? What we end up saying is that we say that this has a correlation factor R. There's a correlation factor R. This should be close to 1. 1 is a perfect correlation factor. That means it's a 1-to-1 dot. It's beautiful, it's gorgeous, so that's 1. Close to 1. Not exactly perfect, but it's very close to 1. This also has a correlation factor, and it also is 1, but I want to highlight something. It is a -1. -1, which means it's very, very strong. So it's very strong, and this word correlation factor. It's very strong. 1 means strong. That means really tight, but this negative means it's heading down to the negative side. So it's down to the right. Up to the right is positive, down to the right is negative. So that's negative. So this one is, this correlation is not close. So correlation factor not close to 1. Right? Maybe a half, something like that, but it's definitely not 1. 1 is supposed to be very nice and tight. Look how pretty that is. Very, very tight. So here again, correlation factor is not close to 1. Okay, maybe this would be, so maybe 0.5, a half, and this may be -0.5. So again, that's in my brain just thinking maybe a half, but not super close, not super tight there. Okay, so how do we use this? We are only going to ask you definitions of this. So I'll give you diagrams and say, is this correlation, does this have a correlation factor closer to 1 or not closer to 1? And you'll learn, if you take data management in grade 12, how to find the correlation factor. There's a mathematical way. We plug in all the values, we divide it all, and then we get this beautiful correlation factor, which will tell us if it's closer to 1, strong, or closer to half or smaller. So this correlation factor closer to 1 means very strong correlation, almost a line. These guys here, not so much, right? So there may be some sort of comparison, so correlation factor. So here, they ask you to make a rough graph, or so talk about whether or not this is a weak or a positive correlation factor. So correlation factor is my question, and so is this a positive or a negative, and is it strong or weak? So I'm asking you positive or negative, and is it strong or weak correlation? So 2 questions. Not what is the correlation factor, but what can we say about it? Is it positive or negative? Is it strong or weak? So when I look at this, I sometimes just draw a little sketch on for myself. So I know that if I study 25 hours a week, I'll get 74. So something like that. If I study 29, so I say this is 25, this is 74. If I study 29 hours a week, I get a little bit higher. If I study 10 hours, which would be over here, I get 55, so it's kind of medium-low. If I study 17 hours, which is a little higher, I'm going to get 84. Oops, it jumped up. Then if I study 3, it'll be 24, so again, lower, and then 28, which is way off here, and I still got kind of this middle. So basically, it's supposed to be doing something like that, but there's these outliers here. So these are called outliers, where they don't kind of make sense with the rest of the data. Those are outliers. So outliers, right, over here and over here. But other than that, this would be a weak but positive relationship. So it's weak because it's not super tight, but it's positive because it's, positive means it's heading up to the right. So positive, and this is negative, down to the right. So that is correlation factor. So then the next page here, okay, correlation factor scatter plot. So this next page here, there's the last page looking at this part, is we're talking about, are these strong, weak, positive, or negative? So this I would categorize as a strong and a positive, up to the right. Positive correlation factor. This one I would consider it to be a strong negative. And when I say strong, it should be close to 1. Close to 1. Right? And this one would be close to -1. Okay. Now here, this one is definitely not a line, right? So this one I would just put non-linear. Okay, we just want to know it's non-linear. They'll ask you some questions. We usually ask you a couple questions about if something is a linear or not. Linear means it has to be a straight line. So linear means, I'll note that on the side. So linear is straight with like a ruler straight. So it has to be, linear is definitely like with ruler straight. Okay? Okay, so linear is with straight, like with a ruler. Okay, so that's nonlinear. This one here, this I want to show you, because sometimes we ask you things about correlation factors, so you'd be like, oh yeah, strong positive, close to 1 maybe, strong negative, maybe close to -1, right? This one you go, oh, nonlinear, look, it's a curve, definitely. This one here, I'm going to go, what? If you get data like this on a science experiment, you would say, what am I going to say? No correlation. No correlation. R is definitely 0. Like, correlation factor is R. Sorry, I think I forgot to say that. R is 1 and R is -1. Sorry, that's, they use lowercase r to say correlation factor. R, I put it over here. So R, so I forgot to put it here. R is -1, so they use lowercase r for correlation factor. So R is 1, and here are not close to 1. Not close to 1. So R. Okay, so R is correlation factor. I'm sorry, I forgot to mention that. Correlation factor is R equals question mark. Okay, so question mark, R. Lowercase r. So no correlation, I would say no correlation are 0. So if you do a science experiment and this is your results, you basically don't have a great experiment going there. Nothing's relating, or it's a good experiment, saying nothing is relating to each other. Okay, so that is scatter plots, correlation factors. Those are neat words you need to know. Correlation factor, scatter plots. Positive is up, negative is down, 1 is the best, 0 is the worst. Okay, 2 more definitions here. Interpolation and extrapolation. So interpolation and extrapolation, extra means more, so it means beyond. So if I have, well, okay, let's just read the sentence I put here. When you interpolate, you are estimating values within the range. So that means, so when you are interpolating something, that means you're reading data from here, within the range of the data, okay, within the line. If my line stops here, but I extend it with my ruler, and I go, but wait, I want to see what happens rest of it, and I do more, but my data, see, look, my data are these dots. These are the data that you got from your experiment. These are my dots. I have no dots here, but I extended the line going, well, I'd like to know what happens here. That's when you extrapolate. So this is called extrapolate. Extrapolate, which means outside of the range. So that means I had data that told me this much information, and I said, okay, that's cool. And then I went, but what happens after? Do you think the line will continue? And I drew the line more. So that is the extrapolate part. This is extrapolate, where I go, well, I think if I keep, so say, for instance, we were growing the tree. if the tree was keep growing, it would continue and I'd extrapolate data, right? So it would continue along there. So that's extrapolate. So here, looking at these two little diagrams here, is this interpolate or extrapolate? Which one is which? So look at the dots. The dots are here. You can't see them very well, but the dots are all here. They stop here, right? So they stop here. So my dots, my data is here. So when I take information from within the dots, this is interpolate, in. So I think of the word in. In is the inside, and then the extrapolate, okay? And what we need to teach you, so based on what we're supposed to teach you, you're supposed to know the words interpolate and extrapolate. Extrapolate means I had my data from my data here, and I extended the line and got more, I extended it and made a hypothesis from extra line, where I extended it to say, well, I think that this theme will continue, and it'll continue like here. Okay, so if I think that my data will continue, I extrapolated it. If I read from within it, that's interpolate. And again, we sometimes just ask you, is this an example of extrapolation or interpolation? Okay, so you need to know interpolate and extrapolate. And that's it. So we've got a lot of little definitions. So interpolate, which is in the data set, and extrapolate means you extend the data and you read something beyond it. We have correlation factors, which are lowercase r. So strong positive means yes, positive. Look how close the data is. Strong positive, it's close to 1. This is a strong negative, r equals -1. This is r equals 0. No, it does not. There's no data here that's telling us anything. It's just a big mess. Nonlinear means it's showing me a curve, not a straight line. So it's called nonlinear. And then again, correlation factors. So this whole page is all about correlation factor. Okay, so we've got a bunch of little definitions about correlation factors, which is lowercase r. It's just telling us how much something correlates, how much something matches. Okay, extrapolate, interpolate. And that's it for these definitions.